Hello guys, welcome to Pre.Code, and today we are solving this problem copy and paste. From last 2 days I'm not able to figuring out this problem. So today we can find the solution. This problem is easy peasy, but still I'm not able to do that. So today we are discussing this problem, and this problem name is copy and paste. In this problem we have a string of length n, and we need to made a new string b by concatenating a m times. Okay, for example, if a is 1 0 0 1 0 and m is equals to 3, then b becomes 3 times of a. Okay, so firstly we can remove this code because we will rewrite it. And then chef calls an index as a good index if prefix of I is equals to suffix of I plus 1. For example, we have this array, this 1 0 1 1 0 1. Now, chef calls an index good if prefix of I, let's pointer will be there. Prefix of I is equals to suffix of I plus 1. Okay. So what does this mean? Pref I is equals to b1 plus b2 up to bj, and suffix of j is equals to bj plus up to the length of string b. Okay, and I think more things will be given. Just this three represent the number of test cases as per the platform's requirement. The first line contains a single integer t, the number of test cases, and then the first line of each text case contains two space separated integers n and m, where n is a length of string a and m become the concatenation number. Okay, and array, the second line of each test case contain a binary string a of length n containing zeros and ones. Okay, so I am telling you that the prefix I, what is this prefix I? Prefix I is equals to the of sum of the sum of ones before index I. Okay, and what about suffix? Suffix of I plus 1 is equals to the sum of ones after index I. Okay, uh, excluding I. That's it. Now we now the chef call index I is good if pref of I is equals to suffix of I plus 1. Okay, and what it does mean, the number of ones before index I is equals to the number of ones after index I. Okay, this is a very simple problem. Yeah, so we can start solving this problem. For example, let's suppose int t, that represent the test cases, and then c in t. Now we can apply a loop. It's just for test cases, for example, 3. Then it run for 3 test cases. 1, 2, 3. Okay. Now, as we saw, the first number will be n, that represents the length of the string, and then second number will be m, that contains the concatenation multiplier, for example, right? So so we have one more approach. I can explain you. Firstly, we can take c in of c and m. Now we have one approach is that if we have a is equals to uh, 101 101 and m is equals to 3. Okay, then b becomes 101 101 101. Okay, so first thing I come in my mind is that prefix of I becomes the substring, right? Substring from 0 to I, and suffix of I plus 1 is equals to substring of I plus 1 up to end, right? Then we can calculate the count for these substrings, and if they are equal, then we can plus the count of good indexes and return it. But here is one problem, that we have to generate this b, a big B. If we have this 30, then I think compiler will take so many time, right? So now this problem is not solved by this simple approach. So we need to play with this. Okay, so I can tell you. We can go with the hint section. So first hint. Uh, as we can see, chef has a binary string A of length, which is then repeated m times to form B. Okay. Uh, See this. If we were able to actually create a large string, solving the problem would be easy. However, it's too large to create, and so we need something smarter. Okay, so what we can think, I can tell you. Firstly, take a string A, taking input of the string A. Okay, now what we can do, firstly we have to calculate for the uh, int total number of ones in A is equals to 0. Okay, now firstly we can find the total number of ones in a single string. For example, let's suppose A is equals to 101. So I can store total number of ones become 2, right? So how we can calculate this? We have to iterate over this string, int I is equals to 0, and up to the n. which represent the length of string A, and then I plus plus. Uh, After that, this is a string. This is not a array. So we are not able to change the type of character to integer, right? We can play with the smarter way. For example, if 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 a of I uh, is a of I minus 0 is equals to 1. That means what is the sky value of 0? For example, as per given in the question, uh, as per given in a question, a binary string of A contains only 0 and 1. So, for example, if the sky value of 0 is x, okay, then 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 we can able to find the number. For example, if we have a number in string 1, then minus 0, then it also return 1, because uh, because sky value of 1 is x plus 1, and the sky value of 0 is x, so it return 1. If we have here 0, then it will return again 0, which uh, which fulfill our desired results, right? So we can play smarter, and if we can return this, then we can increase the count of this. Okay, firstly we can do this. Now what is the idea? If now we can find the k, this k element, right? Okay, we can take one more additional parameter, that is k, which represents the total number of ones in uh, whole string B. So k is equals to a into m, right? Total number of k represents number of ones in B is equals to number of ones in A plus sorry, number of ones in A into the number of copies of A, right? So go next. Now, if if k is equals to 0, what it mean? The A string become 0, 0. No one. If no one are present in a string A, then we get a count k is equals to 0. So answer will be always 0. Okay. See out, see out, 0, enter. Okay. Now if k uh s- what is 2 not equals to 0, then what will happen if k is odd? That also means there is no answer in this. There is no good index if k is uh, odd. I can explain you what will happen here. And here we get n into m. Now, what will happen? K is equals to 0. K is equals to 0, which means there is no 1 inside a string A, right? So if A is equals to 0, 0, and we can multiply it with 3, then we get B, that is again 1, 2, 3, 4, 5, 6, 6 zeros. And but we have to find prefix of I is equals to suffix of I plus 1. So at every index, we get the sum of ones before I and after I, same. That's 0, 0, 0. At every index, we will get 0 in left side, 0 in right side, left, right, left, right, left, right, left, right. Everywhere we get sum becomes 0. If you guys are not able to understand, I can let you explain one more example. For example, we have a is equals to this 101, and we have to multiply it with 3. So what will be the b? B becomes 101, 101, 101, right? So now we can calculate uh, prefix of I, prefix of I at prefix of 0. Prefix of 0 is equals to 1. Prefix of 0 is 1, and similarly prefix of 1, again 1 plus 0, that is 1. Okay. Similarly, we can go next and next, next and next. 2, that is 101. That that means 101. That means 2, right? And similarly, we have to find suffix. Suffix, for example, you can do it by your own. You can see the difference. For example, 101, 101, 101. So the sum becomes 1, 2, 3, 4, 5, 6, 6. Okay. And similarly, suffix of 1 is equals to this one only. That is again 5. And like that, we have to go within all the iterations. And if we get prefix of I is equals to suffix of I plus 1, that means the number of 1 on both sides become equal 1, 2, 3, 1, 2, 3. So here this one will be the good index. 0, 1, 2, 3, 4. 4 will be the answer, like that. Okay. Uh, this one is also the result. So 4 and 5. There are two good indexes, so we can return 2 here. Okay. And if k, what is this k means? K is the sum of ones in B. K is sum of ones in B, right? And if the sum of ones is even, then we have to go next. And if the sum of the numbers, the sum of ones in string A is odd, that means uh, that means string is something like 100, right? And multiplies it to 3. Then what will happen? We get b is equals to 100, 100. So the sum of k becomes 3, right? Now we don't have any index which represents that on my left side, yes, and on my right side, yes. Both sides have equal weightage of ones. So we can directly see out 0 if k is odd. And similarly, when k is equals to 0, 0, 0, 0, that means there is no one present in string A, which also represent that all the indexes are good indexes. Okay, so we can go next. Now we have to play with the m. Let me explain. This is the most tricky part. Okay, if m is even. Okay, firstly go with this condition. Then we have to find like that. mm, 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 If m is even, you have to generate your own examples. Take a copy and pen. You can you can generate and iterate over it, and you can explain this problem very well. Okay, if m is even, that means what it mean? Like a is equals to 101, and we have m is 2. Then what we will get? Then what we will get? 101, 101. So here m is even, right? So we can get this as a good index, right? Firstly, we have to calculate the value of k, and here k is 4. 4 means it's even number. So we can divide the string from the middle, and we also have one more case where m is odd. M is odd. That means if a is equals to 101 into 3, then we get b, and it looks like 101, 101, 101. How we can divide this thing? As we know, in odd, when m is odd, that means we are replacing 3 copies, right? So we can discard left side and right side, and we have to focus only the middle part. If we get the index according to this middle part, then this is our good index, because from both side we can able to trim it, right? And in case of even, we don't need to play with these middle part, right? So go next. We can write the code. If m modulus 2 not equal to 0, that means m is odd. So we have to work only on the middle a part, right? So we have to iterate over the loop, and I is equals to 0, and up to the length of this a. So this is again n. and then I plus plus. Now we have to calculate the sum 101. I can explain you. I can explain you. If as we know, uh, what is k? K means the k means the number the number no total number of ones in B. What it is? Uh, total number of prefix of I plus total number of suffix I plus 1. Right? Can you imagine this? What is k? K is actually the number of ones before I and number of ones after I plus 1, right? So according to question, what is good index? Good index becomes when prefix of I and suffix of I plus 1 is equals to same. What it mean? Let it be x. Okay, let this will return value x. Then k becomes x plus x, right? So we need to play with this thing, and now prefix, let prefix of I is equals to x. Good index when prefix of I is equals to suffix of I plus 1, right? So both are same, and calculate we have to calculate according to this situation, right? So firstly we can take one more variable, that will be int pref and 0. So uh, pref of I is equals to a of I minus, I can explain it, right? I already explained it, so don't confuse. Just pause the video and try to understand what it shows, right? So if if we can ref is equals to the sum the total sum of this a part, right? When we go with the full b string, then we have to calculate the k, right? And if we can trim both parts, like both are same na. For example, 101 101 101. So now we can trim from both side, 10, like 1 1 0 0 1 1. So we get the single middle part, right? So we can also go with the sum of this middle part. So we can get access. What is the middle part? Total number of ones in A, right? Can we write the same condition here, right? then we can increase the index of int good indices is equals to 0. Good indices plus plus. This is the solution. This is the most calculative part. And that's good. That's good. That's so good. And then we can go with the else condition. Here, here m is even, even, even. So here is one formula given in the hints when I can try to solve this. Firstly, we have this second hint. In particular, prefix of I and suffix of I plus 1 always equals the number of ones in entire string. Since B is formed by repeating A m times, the number of ones in B is just m times in the number of. This will explain this part, right? So not a big deal. I can also explain you this thing k by 2. See this. If k is odd, even see, say m, say m is even, then b can thought of as two equal strings of length n, right? M by 2 joined together. Each of these strings is formed by m by 2 copies of a. Okay, hence contains the half the ones of the whole string. What is the answer in that case? So let me explain. See, when m is even, the answer is simply the addition of the following lengths. Okay, I don't know how this formula will be written. I can also confused here. You guys can also share your ideas if you also know what it represents, right? For example, we have to let x be the last position in A such that a of x will be 1. So we can take one variable that is int last one in A, right? What is this m is even condition? Need to explain. Need to explain, guys. I think you guys can understand. Okay, let me explain. If A is equals to 101, 101, 101. No, 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 no. A is 101, taking the multiple 3 times, no, 2 times. Then we get B is equals to 101, 101. So we need to find this middle part because M is even. So according to this statement, B can be thought of two equal strings of length n, right? B is formed by equally dividable parts. Okay, so each of these strings is formed by m by 2 copies of A. Okay, and now it's like a average, right? So here we can discard this, and find our good index. What will happen if number is something different? Let me show like this. 1 1, no, 1 1 0, 1 1 0. Also it's 4 times. Then what we will get? 1 1 0, 1 1 0, 1 1 0, 1 1 0. So now k becomes k becomes 1 2 3 4 5 6 7 8 8. K is equals to 8, right? And m is even, right? So here we need to find the equal ones part. 1 2 3 4. I think I think here is the middle part, right? In between A. So we can find the average something like uh, uh, before, after one, before one, right? Both are the good indexes. As a dot represent good index, right? So we can go with this formula. We have to find the last position of A such that A of x become 1. We have to find the last position of x, last position of x such that it becomes 1. Okay, so I think we can, when I think we have to compute this variable when we are calculating the total number of ones here, right? Um Last of 1 is equals to I. Okay, what next? Then we have to find y such that first position in A such that A of y is equals to 0. True, true. Now we have to find first A, first 0, starting with the -1. What happened? Okay, when we get the first 0, then we have to update the value of this last. No. First 0 is equals to -1. Then we have to update it, right? We will get it. We will get it. We will get it. What next? What next? Now we have to return the answer like the good indexes. We can print it, see out good indexes and dull. Hmm. Now what we have to return? We have to return this formula like good indexes equals to n, which represents the length of that middle part. Then we have to find x, which represents the last one's position, plus add the first zero's position, like that, and we can find it. What is n? Length of n minus first 0, I think last one, and plus first 0. And we have to add one condition, that if first one is equals to -1, then we have to return 0. Otherwise, whatever the value of first 0. And this is the solution of this problem. Now I can run this and show you what will be get. I think we will get the compilation error. Good, good, very good. Okay, it will say a string. Okay. What k represent the total number of ones into m? That's my mistake. Wrong answer. Oh shit, man. Still, I am getting the wrong answer. Why, bro? Why? It's always me. Uh, I think I do all things perfectly, but maybe debug my code. Let's see what happen. 4 2 1. In case of 1 1. In case of 1 1. When we get all ones. When we get all ones. And what is next? 4 times 1. 4 times 1. So we have to multiply it with 4 and b becomes 1 1 1 1 1 1 1 1. Now, what is the value of k? 1 2 3 4 5 6 7 8 8. And it will go to this. And what about m? M is even. M is even. I think we will get something wrong here. And into m, everything will be sorted. Cos equals to -1. Let's see this condition again. N minus x. What is x? The last position of a such that a of x is equals to 1. Okay, a of x is equals to 1. Mhm. Then n minus x. What is this n? N represents the length of string. I think here is a problem. Maybe. No, 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 no. Last position n. Here it play with the a, so n becomes the length of that a part. I don't think so. There is some problem. M is old, even continue. I think we saw the problem. Maybe. Let's submit it. Oof. Wow. Ooh. Partially correct answer. I don't know. I don't know, brothers. And that's it. You can also contact me in the comments to tell me the correct answer. I am still here. I am not able to resolve it properly. I am getting this partially correct answer and go next. If you have some more ideas, then you can let me explain. If you have any doubts, bye bye.